Hello everybody, I'm Storm here. Welcome back to Kerbal Space program. In the last episode, we flew out the refueling vehicle to rendezvous with the longbow, docked it up, and transferred the fuel over. That whole process actually took a little while because I wanted to be very careful with that docking maneuver because the refueling vessel that I built was a big, heavy piece of equipment, and just really needed to be careful with it because one wrong move and I could have ended up slamming tons of unmanned vessel into our manned vessel, which would have been bad. And since they're rather large and heavy, those RCS thrusters don't really change direction very fast, so you kind of have to be careful. But that all got done. Fuel's transferred, undocked the now empty refueling vessel. It's now basically a piece of trash in orbit of Kerbal, the sun. I don't really see any reason to try to go out there and retrieve it. So, yeah, we're just going to let that sit there and basically be a satellite at this point. It has a communications relay on it, so you never know. It might be useful at some point. So, off screen, I went ahead and ran through the maneuver burn that was needed to get the longbow on an intercept trajectory with Kerbin, so that's done. And I went ahead and ran through the burn that was needed to get the ELU probe that we had launched a while back on an intercept trajectory with ELU. So that is all done. So the Joule probe and the ELU probe are now both on their coasting phase to their respective targets. So what I had to do is going to have to get into the tracking station and see what the timing of everything is going to be, so that I can see what the next item is that we're going to have to deal with. Okay, so first is going to be the longbow. The KSS longbow, there you are. Okay, so there's our new trajectory, which does rendezvous with Kerbin here. And that is going to be in 118 days, 1 hour and 44 minutes to enter the sphere of influence. Okay, so the Joule probe will be entering Joule's sphere of influence in 1 year, 100 days. Okay. The ELU probe will be entering ELU's sphere of influence in 2 years, 181 days. Okay. So that's some ways to go there. All right, so the longbow is the thing we're going to be dealing with first. All right, so let's go ahead and regain control. And we will get our Kerbals home. They spent a little extra time out here than anticipated, but that is fine. We have plenty of life support on board. Alright, so we don't need the maneuver planner right now. I think one thing I want to do here before I start advancing time is EVA Dealy. Ooh, ooh. Ooh. All right. Yeah, grab on there. Good. And I just want to check to make sure that we've grabbed... Oh, there's some data. Store it. And we've grabbed all of the data. Take some data there. Store it. Nothing there, nothing there, nothing there. Nothing there, nothing there. Okay. Alright, so just a couple of gravity scans that hadn't been taken care of. So I'll just reboard there, and then I'll go ahead and transfer Dealey to the habitation unit there, the larger one. Not going to spend the next 181 days in that cramped little capsule. Alright, so let's go ahead and advance to the point where we are back to Kerbin's sphere of influence, because we have another big, long burn to go through. Which, you know, as usual, I'll be pausing the recording while we take care of that. Yeah, we're going to be a little bit out in front, but we're going to go at a higher orbit slightly. And then that should slow us down enough for Kerbin to catch up. Yep, warp to right about there. 5 more days. Alright, so I'll just manually warp. Okay. There we are. What is it asking us for? A gravity scan. I'm not going to worry about a gravity scan right now. Alright, so I'm going to be using MechJeb for this because it's just going to be easier. It's not like anything different. What we're going to do is we're going to circularize at the next periapsis, create the node. It's going to be a 12-minute long burn. Go ahead and execute the node. No, turn the RCS off. We don't need the RCS. This has reaction wheels, which are perfectly fine. Let's go ahead and fire that reactor back up. I did turn that off. But this is only like a day out, so, you know, we can let it go. Alright, it's going to cost 2,000 meters per second. We got 6,000 in the tank, so plenty. Alright, so there we are. Right, and that burn's going to start there. Okay. Hitting the brakes. Now I got 12 minutes of burn to get through. Alright, so we'll go ahead and pause it while that gets taken care of, and I'll be back once we're about done. Alright, and we're back. Got 260 meters per second of delta V left to burn off. That's a minute and a half. Let me just take a look at the current orbit. The current orbit is fine. I might not actually reach the exact orbit that I was looking for, but that's fine. That's not a problem. Because this was just get it close enough, but not too close kind of orbit. We're heavily inclined, but that's okay. I'm not too worried about that right now. Alright, it's just another minute to go. And yes, we saw that the other probes are more than a year out from their destinations. So I think at this point, this load of science that we're bringing back should be enough to unlock the stuff I need to begin building the Moon Orbital Station and starting to set up the resourcing operation that we're going to need there. So, yeah. That is what we're going to do next. Once this is done. Oh, and once our Kerbals are safely back home after a fairly long trip. Alright, 20 seconds. And actually, we are going to get pretty close to that orbit. That circularized orbit. Three, 2, 1, and cut off. Well. Throttle down and then cut off. There we go. Yeah. Okay, now, do I want to change... Now, see, the thing is, I'm on a retrograde orbit. I'm on a retrograde orbit, right? I'm going this direction instead of this direction. Right? Yeah. I'm going counterclockwise instead of... No, I'm going clockwise instead of counterclockwise. Well, looked at from that direction. Anyway. Retrograde instead of prograde. Okay. So if I wanted to flip this to a prograde orbit and change inclination to 0... We're looking at a 3,000 meters per second burn. No. What if I were to remove the node? And then you do 180 degrees. So that would be a flattened, but still retrograde orbit. Create the node. 812.4 meters per second, which is going to be a 4-minute... Okay, I can actually do that later. I do want to move this into the moon orbit and start getting it prepped, but I'm not going to worry about that too much. Now, I did want these thrust blocks for tugging stuff, but... We'll see. Alright. First order business is going to be... We need to get some fuel into the lander, because the lander is what we're going to use to get back home. Let's see. We need to transfer crew Valentina to the lander, right? Transfer crew Dealey to the lander. There we go. And these are what? These are the LFT 12-1 lithium tanks. I don't need a lot of them. Let's see. Lock, highlight, transfer in, transfer out, balance, dump. Now, let's see. Out, balance. That should be enough. It's probably still excessive. Let's see. Out, and then balance. Yeah, that should be fine. Alright, let's go ahead and undock. Undock. Oh, that reactor needs to shut down. For now, anyway. Shut down that reactor. Okay. Alright, extend our radiators. Fire up this thing's reactors. There we go. How much Delta V do I have? 1100 Delta V. That's perfect. Could probably gone with even less. Alright, so if I want to point this thing retrograde, there we go. Now, this whole section's getting ditched once we get into the atmosphere. Now, we actually are going to recover this instrument panel. Instrument bay. I guess I'll take the gravity scan because why not? It's 30 extra science. Alright, so we're orbiting in this direction, so I don't necessarily want to land at night. So let's do a maneuver node right about here. And I want that periaps at around 30,000 meters. 30 kilometers, give or take. Nope, 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 way too much. That'll do. That'll do, I think. Maybe, yeah. Yeah, that'll be fine. So we have a 1 minute burn. Let's go ahead and warp over to there. Alright, this means that I want to start the burn at T minus 1 minute and 36 seconds. 36 is 18. T minus 48 seconds. Though it's not that critical if I hit it exactly. This is just a rough estimate. Three, two, one. I guess I'll do another gravity scan. Why not? And engines on. All right, 1.5 minute burn. And I guess I could try and bring the whole thing back. No, that thing will be a bad idea. This isn't built for that. Because this thing's thrust is going to drop off dramatically in the atmosphere. It's not going to be able to provide any thrust at all. And these two parachutes are going to be nowhere near enough to slow this whole thing down. So yeah, we're just going to have to ditch everything. Alright, periapsis height is coming down. We have 25. Yeah, no, we're not doing a crew report. Periapsis needs to come down to about 30. So right up. Why are we locking up? There we go. Close enough. Alright, I don't want to ditch everything just yet, but what I'm going to go ahead and do is I'm going to shut the reactors down. Reactors are offline. Fold up our radiators. And then let's warp to where we need to be. Alright, slow down, slow down. Alright, turn that off. I want to spin up. And this better work. Jettison. Excellent. That will do. Our heat shield is still good. Get rid of some of this clutter a little bit. Alright, we are entering the atmosphere. I did not necessarily want to launch that piece of the lower part ahead of us, but that's okay. It's going to be heavier than us. We're going to slow down faster than it, so we're not going to risk running into it. And if it starts exploding, we'll have a front row seat. No, actually it is slowing down faster than us. Significantly faster than us. Probably because it's slightly lower in the atmosphere. Even so, we're fine. There it goes. Boom. Something broke off. should be coming down at a shallow enough angle that this should slow us down. Yeah, we're still actually not in a suborbital yet. But periapsis is dropping further and further and further into the atmosphere, so yep, we're definitely going to impact. I'd rather do it in the water if at all possible. But that doesn't look like that's going to happen. We're definitely going to come down over land. Thing is, I've grabbed most of the science. Well, yeah, most of the science from the science package there. So even if we lose the cargo bay there, we should be fine. Cargo trunk, I think they might call that. So yeah, we have 2 nuclear reactors that are re-entering the atmosphere uncontrolled and are probably going to make it all the way to the surface. So yeah, that's a great idea. I just thought about that. Alright, turn off the SAS, kind of let this thing go aerodynamic. Alright. We are through. We just need to get that surface velocity down to a manageable amount. I usually like to do it around 280, even though it doesn't really matter. There you go. Chutes are out. And we're coming down in a relatively flat area, so that's good. Almost made it to the water again. Well, no, we would not have hit the water. Alright, well, I think that we are good. I'm going to go ahead and jump this up to 4 times. .7, 5.6. I can actually jettison the heat shield. And that'll slow us down even more. Just dump an unnecessary weight there. And there we are. Let's recover, and let's see what we got. $3,452 science returned. Excellent. Crew, ready for next assignment? Everything's back. All right. Excellent. Let's see what we can get. I haven't really done anything with planes. We probably will here at some point. But one thing I'm going to need is hydroponics. So I need the hydroponics modules. We're going to need that for Nomomedic. For the space station. Short-term habitation. Habitation modules. Inflatable habitation modules. That might be useful. Expedition rover. Long-term habitation. Aquaculture modules. Hydroponics modules. Kerbitats. Agricultural modules. Yeah, this is kind of stuff we're looking for. You know, I think those are really intended for kind of permanent surface habitation. I can use them for orbital hab as well. So that'd be what, 550 and 1,000? Yeah, easy. Do it. Grab both of those. Can't do my advanced plasma propulsion just yet. But I'm not really worried about propulsion at the moment. Large probes. Octogirder guidance unit. That is something I actually want. Because I'm going to be using the octogirders a lot for this. Relay tech oh yeah. Yeah, we're going to want to grab that. Advanced photovoltaic materials. Do I need that? Off-world robotics, orbital assembly. Assembly plant? Docking connector, octogirder. Ooh. The advanced photovoltaics. Well, these are nice. I don't think they're necessary. But the octogirder modular truss angular, octogirder pressurized truss angular, octogirder modular truss hub. I'm gonna need that too. Docking connector, octogirder, docking connector. Octogirder Senior. Clampetron Docking Port XXL Mondo. Okay. Payload fairing 7.5 meter. Okay. We also need some of the larger... rockets. High-performance fuel systems. Yeah. While some of these are nice, it's not necessary. But I think I want some of these. The pressurized truss hub, the pressurized truss, the modular truss hub, configurable adapters, spinal modular truss B, spinal modular truss D, another adapter. Turret modular truss. Yeah, we'll grab that. And that burns off all of our science. Yeah, 3,000 science didn't really go very far, did it? Oh well, we got some stuff we need. Alright, so let's start designing... what is going to be the core of the new space station. To do that, what I want to do is I want to go to Structural, and I want our Octogirder Modular Truss C. I think that's the one we want. Subtype, I want to be support. So this is going to have monopropellant and electric charge. Alright, so this is going to be the battery pack. Primary battery pack for the start of the new station. I'm going to want the Octogirder Guidance Unit, because then that will provide control. Does it also have a reaction wheel? It does have a reaction wheel. Stability assist. Prograde, retrograde, radial, normal, maneuver hold, target tracking. Okay, so yeah, it's a pretty decent unit. Okay, good. Now, do I want this to have... Well, let's just get some more of it designed. I kind of already have in my head what I really would want on here. I want a couple of hubs on it. Now, it's going to need to be able to dock both large and small docking ports. Alright, so I'm going to want that adapter there and this adapter here. Alright, to adapt to round. Right, okay. No, none of this is going to be pressurized just yet. This is all going to be unpressurized area here. Right, because there's going to be a pressurized side, and there's going to be an unpressurized side of the station. So we're going to take the senior docking ports, put those on the ends. And I think that for now, what I'm going to do is I'm going to put some more of these adapters on. No, not that one, this one. There we go. There. Okay, so we're adapting to the octogirder to a round. And that's a 2.5 meter round connector. Do I have any adapter that drops that down to 1.25 that's relatively low profile and still kind of has the truss look? Huh. These are turret model. Let me just drop that on there. Do these things have subtypes? Select core. Solid? Okay. Select truss. No. Cancel. No, they are just open trusses. Okay, so see, no, this is like a it's a side angular piece like that. I guess I could use those. Well, this is going to need some solar panels. So I kind of want to keep the docking ports out of the way a little bit. No, that's not exactly what I'm looking for. No. It's more something like this. That's not the worst thing in the world. It'll do. It's also going to need some communications equipment. This piece really shouldn't need RCS, but I'll probably put some RCS on here anyway. Okay. Now, for solar panels, oh, well, docking ports need to be on there first. Clampotron docking port. We don't want the junior, we just want the standard. All right. Get all these on there. There we go. Okay. Yeah, that'll know how to do. Now, Now, as far as power goes... we can put... Actually, let me put them on the corners here. Solar panels there. Let's see, how much power is that? 8 per second. Oh yeah, perfectly fine. Because the control unit requires, what, 4.8 per second? Alright, for communications, I'm going to use some short-range communications. And we're going to need some long-range communications. Well, at least enough to get back to Kerbin. So, what do we need? These guys, right? 1.12 gigameters. $61.2 gigameters. But that is a nice, compact... Because when it unfolds like that. So those are fairly nice and compact, even though they're overkill. I'm not putting those on there. No, because they extend like that. Let's see, 22.4 gigameters. I mean, that could go on there. It's not the worst thing in the world. Let's see. High gain antenna, 2.83 gigameters. Alright, what do these look like when they extend? No, not exactly what I'm looking for. I mean, these are also not bad. If I were to, maybe put them like this. And they do clip a little bit. What about these? They extend. But yeah, they're going to interfere with anything trying to dock. That's going to be the one issue there. 354 megameters. Megameters. I think I'll put one of these on there. I think it's probably the best option. I just want to flip it around. Oh. No, not that way. Not that way. There we go. That way. No, that doesn't quite work, does it? I was trying to put it on here somewhere where it doesn't look like it's going to be floating in open space, but you know what, so be it. It's got the low profile and it's got the range, so that will work. Alright. So as I was saying, RCS. I need some RCS. Now, these are going to need to be monopropellant-based RCS. Advanced RCS block. See, I don't know if putting that there is a great idea. Oh well, but that's what we'll do. We'll put it there. And hopefully it'll be able to sort itself out. It doesn't really need it, but we're going to throw it on there anyway. Okay. So, this is going to be the Moon Station core. Alright, now I just need a rocket that'll get it there. Probably be using 3.75 meter rockets. Yeah, that'll do. Trying to decide how I want to control it. Because, let's see, if I put that there, well, actually the way I would probably want to do it is put that there, put that there. It would need some sort of battery. Right about there is fine. Got some batteries. Alright, for a fuel tank, this. I don't think I want to go cryogenic. LH2 aux? No. No, see, that's too small. The Titan motor. That would definitely get the job done. But I think the Wildcat might be better. Let's see. 310 vacuum ISP, 335 vacuum ISP. Yeah, that's better. 3,000 meters per second on Delta V. That'll do the job. Alright. And then we'll just do the standard stuff. It only provides 1700 meters per second at delta V. What if I put the Titan on this one? 1900 meters per second with a 2.33 thrust to weight. Yikes. What's the thrust to weight on this? 3.15. Yeah, that's overkill. We'll use the Titan. I could also use the Rhino. 1.34 thrust to weight. 1.34? With 2,000 meters per second at delta V. That's actually better. And if we can give it something to give it a little bit of kick off the pad. Thrust to weight on this thing is 2.41. 3,000 meters per second delta V. Yeah. We just need something to give this a little bit of a kick off the pad, and then I think that'll get us where we want to be. So for that, we're going to throw on some solid rocket boosters. I haven't really used those a lot, so yeah, let's go with some solid rocket boosters. The Thors. 950 meters per second of delta V out of the Thors. With 1.3... Probably want to move these down a little bit. Yeah. Now, these don't have any gimbal control. So, what we're going to want to do is we probably want to give this some aerodynamic control. Or I can use some reaction wheels. Yeah, that'll do. Alright, let's get the launch clamps. And then let's check our staging. Make sure that that's all staged correctly. Well, actually, this is also going to need... the fairings. There we go. Alright, so we're going to want to release the clamps and fire the solid rocket boosters. I probably actually want to put both igniting that engine and detaching those on the same... No, I want to keep those ones separate. Detach that. Fire that. Deploy the fairing. Yes. Okay. Alright, so let's go ahead and launch it. And I think I am going to use MechJeb for this one. I manually flew the last one, But for this one, this is a really simple launch. MechJeb should be able to take care of it without any trouble. And this is going to be a matter of getting it out to the moon and getting it into the correct orbit. And then getting the longbow over to it and then docked. That's going to be part of the deal. And then figure out how it is that we're going to dismantle some of the longbow for parts. Which parts we're going to want to use and which parts we're not. Also want to start designing a new manned vehicle. Ascent guidance. Let's see. We're going to limit Q. Yes. We're going to auto stage. 100 kilometers is fine. Engage the autopilot. And hit it. Uh-oh. Disengage and re-engage the autopilot. It was on the wrong orbital inclination. There we go. Fortunately, I caught that while we were still in just a straight ascent phase. Or that would have been bad. Electric charge is fine. Yes, there's lots of electric charge available. Saw rocket boosters are overheating, but they are about to run out. Alright, thrust to weight is up to 1.5. Now, it's given us a lot of horizontal velocity here at this point. And why did it shut off the engine? Alright, disengage the autopilot. Did we lose communications? No, we have communications. Why do I not have throttle control? I don't have throttle control. Signal strength is 100%. There's fuel in the tank. Good thing this is unmanned. I mean, the engine is gimbaling. Okay. Well, that was weird. Back to Space Center. I have no idea. Let's try that again, shall we? But this time I'm going to do it manually. Unless that reorientation with MechJeb screwed it up. Now let me try it one more time with MechJeb. I think I messed it up. Well, no, there was something weird going on there. Alright, but at least let me turn off the limit queue, turn off the auto staging, all that kind of stuff. Turn that all off. Alright. I'm going to do this manually. Alright. Let's go. Once we get to about 2,000 meters, I'm going to start nosing over. Alright, I want to be to about 45 degrees at around 10,000 meters, which is where we're just about at. Alright, we're going to head at this angle for a little bit. Yeah, we're just going to kind of run at this angle, 30 degrees it looks like. Yeah, 30 degrees plus or minus. Apoapsis' height is still climbing. $50,000 kilometers. 80, 90, just over 100. Alright, we coast. Let's set up the maneuver node for the orbital insertion burn. It's going to take 400 some odd meters per second. That's perfect. Alright, hold the maneuver node. It's going to be a 21-second burn, which means T-minus 10 seconds, give or take. We're going to go ahead and do that. We're going to be jettisoning the fairing here momentarily once we get above 70,000 meters. There we are. Get rid of the fairings. So it's what, T-minus 10 seconds, right? I don't know why the burn time is screwed up. Alright, get ready to burn. Actually, it's T-minus 10.5 seconds. So at 11, we'll pause for half a second and then start burning. And then we can let it overburn for just a little bit. And there we go. Done. And we are in orbit. Excellent. And why is it not reporting how much delta V I have? So weird. Okay. Delta V total 2,254 meters per second. We're going to need around 800 to 900 to get to the moon. And yeah, then probably a couple hundred to circularize once we arrive. Okay. But what I think I'll do is save that for next episode. Yeah, we'll go ahead, get this thing to the moon, and then get the longboat to the moon, get it docked up, and then figure out what it is we're going to be doing from there. Alright, so we'll stop here. So I hope you guys enjoyed it. Thanks for watching. Go ahead, like, subscribe, and comment, and I will see you next time.